Today I'm going to take you through a practical DevOps project that's going to teach you the tools that you need to know as a DevOps engineer. This video is not only going to show you the tools, but give you valuable insight on the tasks that a DevOps engineer takes on a day-to-day basis. By the end of this video, you're going to learn how to use Vagrant, Ansible, Docker, and Docker Swarm to create your own DevOps lab. We first start our project by provisioning 4 Linux servers using Vagrant. Once the servers are provisioned, we are going to use Ansible to create and run a playbook that will automate the configuration of the servers. After the servers are configured, we will containerize a simple web application. Finally, we will convert our servers to Docker Swarm nodes and bring up the application on the Swarm. This is the perfect starter project for learning DevOps, and it's something you can take further and expand on as well. Let's go ahead and get started. Alright, let's go ahead and get started with the first practical section of this project, which is setting up Vagrant, VirtualBox, and then using Vagrant to bring up our servers. Now, you don't have to follow along and do this yourself, but I have all the commands available in GitHub in the description below, so if you want to use that and follow along, that's great. But if you want to just watch and see what a DevOps engineer does, that's fine too. Either way, you're going to learn a lot. So let's go ahead and get started, and the first thing we want to do is install Vagrant. So again, I have all the instructions in the GitHub below with the links to these websites. So the first thing you want to do is go on over to the Vagrant installation website and then go to the Vagrant downloads page. Once you do that, just select the operating system that you're interested in. For Windows, you just download a binary and install it, and for Linux, there's a couple commands that you're going to put in. Once you have Vagrant installed, the next part is to install your provider. So there's a lot of different hypervisor providers that you can choose from, but the one we're going to use in this lab is VirtualBox. So under the Vagrant documentation, you can see all the different providers that Vagrant allows you to use. You can see that we have VMware, Docker, Hyper-V, and VirtualBox. So we're going to use VirtualBox for this lab. So just go on to the top and then go to this list, and it's going to show you the compatible versions of VirtualBox that you can use. So you want to make sure that you're using the right version of VirtualBox to get all this working. So we'll go here, and you'll want to download VirtualBox 6.1 or whatever the latest version is. This lab should work the same no matter which version of VirtualBox that you use. So once you have Vagrant and VirtualBox installed, you can check VirtualBox by going up here and opening it up. And I have a clean slate environment here, so let's go ahead and get started with Vagrant to provision some virtual machines. So we're going to have 4 different servers. The first one's going to be our control workstation server, which we're going to install Ansible on, and we're going to use that server to push out configurations to our 3 other servers, which are going to be the nodes in our Docker Swarm cluster. So let's go ahead and get started. I'm going to pull up a terminal here, and we're going to clone the repository and get started with Vagrant. Okay, we're back in GitHub here, and we want to grab this URL and go to our terminal, and we want to clone it down. So we'll clone it, and then we're going to hop into that directory. And let's open up our code editor. I'm using Visual Studio Code, and you can see that there's a couple files here. We have a README, which I will fill out later for you guys, so it's going to have some instructions there for you. And then we have a host file. This is the host to IP address mappings. We're going to copy this over to our control workstation just so it can have name resolution to the other servers. And the last file we have here is our Vagrant file. This is your first introduction to infrastructure as code, and you can see here that it's pretty easy to read and sort of understand what's going on here. Basically, I'm provisioning 3 servers in this configuration and then setting some settings like the host name, the image name, IP address, and then the port that we're going to SSH on. You can see that it's not using 22. You can see that I'm doing 2200 and then incrementing it up. This is because they're all going to sit on the same box. so it's nice to have them on different ports. Underneath here, we have some additional configuration. This is basically just a for loop saying for each of these servers, and then it goes in and it sets some additional settings. You can see that I'm setting the number of CPUs and the amount of memory. So if you want to, you can just make some changes to these settings to customize the servers as you need to. Now, having a look at this, you can see that there's only 3 servers, but we want 4. We want the control server and then 3 nodes. So if I want to make an additional server, all I need to do is take this, copy it, and paste it down there. Make sure to include this comma, and that should be good. Now we need to just make these settings unique. So let's make it have a unique SSH port, and then the IP address will go 53. So one thing about these IP addresses, I didn't just pick them randomly. I went into VirtualBox and I went to File, Host Network Manager, and it pulls up all the VirtualBox Ethernet addresses, and I just made sure that they are in one of these subnets. So you can see that I'm going to be using Virtual Adapter 6 for this project, and I'm making sure that they're in this 172.16.1.1 subnet. So if you want to customize this, you can go ahead and do that and use your own specific IP address range. So I just wanted to show that quickly. Let's head on back into Vagrant. Okay, so we're back in the Vagrant file, and I can see that I didn't change this host name. So let's change that to node 3. And now we're ready to begin provisioning. So I'm going to go into our shell here, and let's clear the screen and do an ls, and you can see the Vagrant file right there. So now I'm ready to bring up my virtual machines using Vagrant. So the command to do that is Vagrant up. So that should be enough to bring up our virtual machines. As they're coming up, we should see them being created in VirtualBox here. It's going to take a few minutes, so I'm going to speed it up. But before I do that, I'm going to show you guys a couple commands that you can reference in the GitHub. I have a link to this in the GitHub. So let's go here. And this is the link that I'm going to give you guys. It's a Vagrant cheat sheet, and it's basically all the commands you're going to need to use Vagrant. So this cheat sheet shows you basically everything from how to create VMs, starting them up, logging into them, stopping, and cleaning them up. So it's a great reference if you haven't used Vagrant for some time. You just pull up this cheat sheet and it gives you all the commands that you need. I also have a good playlist on Vagrant, so if you want to learn more about using Vagrant and all the ins and outs, all the commands, and all the nuances of it, go ahead and check out the video. All right, so let's head on back in. You can see that we got about 3 virtual machines coming up here, and node 2 is being provisioned, so it's probably going to be another minute or so. One thing that I'll mention here is if you run into any errors, just leave them in the comments below or join our Discord and we'll try to help you out. But usually just going out to Google and copy and pasting the error there, you're going to find a solution for it. There might be a few things specific to your workstation, so just Google the error and you'll probably be able to find an article that can help you out. All right, so Vagrant has finished provisioning our virtual machines. Let's hop into VirtualBox here, and you can see that the 4 virtual machines have been created. If we go into Visual Studio Code, you can see this hidden directory. Basically, this is Vagrant storing the state of the virtual machine, so it's good to know that it's there. Another thing to mention is everything in this folder where the Vagrant file is going to be shared to the Vagrant hosts. And I'll show you how to access that directory because it's going to be important to know how to access these files. The first thing we're going to do once we get into our control workstation is copy this host file over to the right location. So let's go ahead and do that right now. So back in the terminal, let's clear this screen. And to SSH into our machine, we just go Vagrant, SSH, and since we have multiple Vagrant hosts running within this directory, we need to specify the name. So we're going to go control, which is the name of our virtual machine. And it took a second there, but it's up. If it asks you for a password, the default password for the Vagrant account is Vagrant, so make sure to use that if it's prompting you for a password. Now that we're in, let's hop on over to the directory called /vagrant. And if we do an ls-la here, we can see that all the files match up exactly with what's in our host directory. So the files are shared between your host and your Vagrant servers. Okay, so now that all our servers are up, let's use Ansible to push out configuration to them. So the first thing to get Ansible working is we need to be able to connect to those workstations from our control station. And to make SSH work, we need IP connectivity, and it's nice to have name resolution as well. So if I were to go ping node 1, you can see that name resolution isn't working, and that's because the ict/host file doesn't have any information on these hosts. So I created this host file right here that has all the IP information of the host. So let's copy it over to our control workstation's host file. So we'll just go copy hosts to ict hosts. And I probably need to do a sudo to do this as root. So let's do that. And now when I go ping node 1, you can see that name resolution is working and IP connectivity is there. Okay, so once you have IP connectivity and name resolution working, the next thing you want to do is make sure that SSH connectivity works. So I think in our setup that SSH connectivity should be there by default, but I'm also going to show you the commands you can run to create your own SSH key and push it out to the servers, as this is probably going to be a likely scenario that you run into. So first of all, let's just test to see if SSH works. So go SSH Vagrant at node 1, Vagrant for the password, and you can see you can get in. So let's exit out, clear the screen, and head on over to GitHub. And in here, underneath the solution, underneath Ansible, I have a couple commands to make the host SSH accessible. So you can run these commands, and I'll just run through them as well. So the first one is to create an SSH key pair, and you can see that it's saving it at this location. And then the next step is to actually copy over that SSH key to the servers. So we do this, hit yes, put in the password for each one. And now when we go SSH Vagrant at node 1, you can see it logs in directly and it doesn't request a password. So that's the benefit of using an SSH key file. It's not going to prompt you for a password when you try to SSH into the workstation, which would be very inconvenient when you're running an Ansible playbook. You don't really want to be putting in passwords when you run the playbook. You want to just run it and it goes out and pushes everything out. Okay, so once you have SSH connectivity to your other servers, we can start using Ansible. So let's go into Visual Studio Code and get started with Ansible. So I'm going to create a new directory here, and I will call it Ansible. And then within that folder, I'm going to create some new files. So I'm going to call one my hosts, and this is going to be our host inventory file. And then I'm going to create another one called playbook1.yaml. Now let's go ahead and start populating these files. So let's go into my hosts, and I'm going to go to my GitHub, and you can see I have this file right here, and I'm just going to copy it and paste it in. So this is a very simple Ansible host file. So just to provide a little more information on this, Ansible has two different formats. You can have inventory files in, you can have it in this basic way that I'm doing it here, or you can have a YAML format. So let's just start off in this basic way, and when you want to sort of learn more about Ansible and how you can change this to a YAML file to get more customization, you can start to customize it later. But this is enough to get us started and push out configuration from the control station over to the nodes. So just to describe quickly how I have this set up, I have this section here called control, and then this one called nodes. There's also magic words in Ansible that would refer to everything, and that would be like the keyword all, and you could push configuration to everything within this file. So this one's good because I'm either going to push out configuration to just the control station, or I'm going to push out information to just the nodes. So this is a pretty simple project with only 4 servers, so there's not much to this, but you could organize this any way that your enterprise organization wants it to be, right? So you might do something like web servers, and do like Web 01, Web 02, and then like database servers, and like DB01, DB02. There's also ways to combine groups within groups, but that's sort of out of scope of what we're doing here. If you want to learn more about the inventory file, I have a link up above that you can go out and check out my Ansible course, and it'll teach you everything that you need to know about the inventory file. So let's go ahead and clear this out and move into our playbook. So the playbook file in Ansible is a pretty special file. It's basically everything Ansible's going to do when you run the Ansible playbook command. So let's go ahead and take this and go into our playbook. And I'm just going to copy this over because I think just explaining it is going to make it pretty obvious what's happening here. So in this playbook, you can see that it's referencing the nodes group. So all the servers within this nodes group, node 1, 2, and 3, are going to do these tasks. So let's have a look at these tasks here. We have 3 different tasks. You can see each of these tasks have a name, and these are just the names that I put in there. So I said for the first task, ensure that Docker is installed. So how would you install Docker on a workstation by itself? Well, if I were to install Docker on a station, I would go sudo apt update, and then once my cache is updated, I would do a sudo apt install docker.io. And then after that, I would do a sudo docker install docker-compose. And then after that, I would add a user to the Docker group. So instead of doing that manually on all our hosts, we're going to use Ansible to do it. So let's have a look back here. So we have the docker.io, we have docker compose, and then we have the user Vagrant being added to the group Docker. Now, one more keyword that I like to add to these apt commands is this update cache yes. And basically this is equivalent to doing a sudo apt update. So we have these 3 commands. Let's go ahead and run them. But before I run them, let's make sure that basic Ansible connectivity is working. Okay, so before we run the playbook, I actually want to test just basic Ansible connectivity without running the playbook, and just make sure that all the hosts can respond to what we call an ad hoc Ansible command. So to run an Ansible ad hoc command, just go Ansible, and then specify your group. Now our groups here are control or nodes, and that group was specified in the inventory file. So we'll go nodes, and then we're going to go -i to specify the inventory file that we're using. So we'll go my hosts. And the reason we specify this is you could have multiple inventory files, like you could have one for QA, production, staging, whatever you need, right? So that's why you might have multiple inventory files. If we go -m, this means module, and we want to run the command module, and then we're just going to go hostname. So basically what this command is going to do is it's going to talk to all the hosts within the group nodes using this inventory file, and it's going to run the command hostname. So all the hosts should return their hostname. And you can see that it doesn't run unless you install Ansible. So let's go ahead and install Ansible. So we'll go sudo apt install Ansible and hit yes to that. And this will just take 1 minute. Okay, so it looks like Ansible installed. Let's rerun this command. And we got an error. And a couple things wrong here. So let's clear the screen. We're in the wrong directory. We need to be in the Ansible directory. And the reason for that is that's where our host inventory file is. So in the command that we ran, it's specifying my hosts. So if you're doing that, you need to specify the qualified path. So it's just easiest to be within the Ansible directory. So you can just specify it like that. The next thing that we got wrong here is I actually need to specify -a. And this is for argument. So it's the command module, and it's specifying the argument of hostname. So let's go ahead and try this. And that looks a lot better. So you can see node 3 came back node 3, node 1, and then node 2, node 2. The next thing you want to do is run this other command from my GitHub, which installs Python, and this just gives your Ansible hosts a lot more functionality. So let's copy this and paste it in. And I didn't copy that, so let's try it again. Paste that in. And this is installing Python simple JSON. Again, this is just going to give your Ansible hosts more functionality for your playbooks, and it's just something I do whenever I'm working with Ansible for the first time. So all these hosts have successfully installed Python simple JSON. Let's go ahead and run our playbook. So clear the screen once more. And then to run it, we run the Ansible playbook command, followed by specifying our hosts inventory file, and then our playbook. So let's take this, put it in, and it wants the sudoers password. And the reason it's asking for this is in this playbook, it has this argument become yes. So basically what this argument says is become the root user. And if you want to become the root user, you got to give the root user password. So we'll go ahead and put that in. And now you can see that it is running through the Ansible playbook. And the first thing that you'll notice here is it's gathering facts. Facts are exactly what they sound like. They're just facts about the host. So you can use facts on the host to make logical decisions of which software should be installed, things like that. It's sort of a little more advanced topic when getting into Ansible, and I explain it all in my Ansible course. So if you haven't checked that out already, go ahead and check that out. So that's our first play in our playbook, is ensure Docker is installed. After that, it's going to ensure Docker is installed. Let's call this Docker Compose. That makes a little more sense. Okay, so next thing is it's going to ensure Docker Compose is installed, and then it's going to add the user to the Docker group. So I'm going to go ahead and speed this up and have a look at the end results. Okay, so it looks like our playbook has successfully ran here. All the tasks have finished. If you're following along, I hope your playbook has ran successfully as well. If you ran into any errors, I would just take your errors and pop them into Google and see if anything comes up. A lot of the time, the issue is connectivity, or maybe the playbook you have has some differences than the one I have. So just make sure to check your syntax and make sure your playbook looks sound. So now that we have Docker installed, let's just go on to one of these nodes and just verify that Docker's working. So let's SSH into node 1 and let's go Docker. And you can see that Docker is working. It's giving us back a list of commands. So that's how easy it is to push out software using Ansible. And you could take this playbook and add as much logic as you want to. You could basically set up anything that you could manually using Ansible. It just takes practice and work to get these playbooks working. There's also things like Ansible roles that really help you out. So make sure to look into all of that if you want to learn more about configuration management. For this video, I just sort of wanted to introduce it as a concept so you'd be familiar enough to go out and take it further to get your servers configured the way you need them to. That brings us to the third section of this video, which is Docker. And Docker is a way to containerize applications, and it's one of the most important things that you need to learn in DevOps or just IT in general. Basically, every service or application is getting containerized now. It's very infrequent that you go into a server and manually install software on it. There's usually some sort of containerization. So knowing about containers is really a must for DevOps engineers. So to get started, let's create a new folder and we'll call it Docker. So once we have this Docker folder created, let's add a new file here. And we'll just call it Docker file. And one more thing I'd like to show, just to test out Docker and make sure it's working, you can go docker run hello-world. And this is going to go out and download the Hello World image from Docker and then run it and return Hello World. So that's another way to test Docker. Just thought I would show it. It's just a good thing to do to verify Docker is working. So going back into Visual Studio Code, let's create a Docker file. So I have one in my GitHub here. So basically what a Docker file is it's a way to create a Docker file. This is sort of the infrastructure as code portion of Docker. So let's just copy this over and paste it in, and I'll explain how it works. So you can look up all this syntax on the Docker website, but just to break it down simply, the from section is the image that we're using. So we're using a Python image running on Alpine. Alpine's just a lightweight Linux OS. And then we're setting the work directory to /code, and then we're using Flask. Flask is a lightweight web framework. It's setting some environment variables that Flask is going to use. It's making sure that some software is going to be installed. It's going to copy over this requirements.txt file, and then it's going to do a pip install requirements.txt. So requirements.txt is a file used in Python applications to specify the modules that they need. So basically this is taking the file, copying it over to the container, and then using pip to install those requirements. The last few things here is expose 5000. It's exposing the port 5000 to the host container. So you'll be able to access the Flask web server if you do like a curl on this port. And then this is just saying copy all the files from the current directory to, I think, this code directory. And then the command is to run flask run. So this is all we need in our Docker file. The next thing we should do is create this app.py file and the requirements.txt. Let's actually have a look at the GitHub. And you can just copy over these files or create them yourself. But we want this one. And we'll create it in our Docker folder. And then the requirements.txt, we actually only need Flask. So I'll just create that. Go new file, requirements.txt, and we'll go Flask. So really simple Flask application here. If you don't know Python, that's fine. Basically, it's saying import Flask, import socket, and it's just running a super lightweight web server that returns hello world and then the host name. So now that we have our Docker file, which specifies to run our Python application, let's go ahead and use Docker Compose. And Docker Compose is just a convenient way to specify how our container should be built and run. So go new file, docker compose.yaml. And you can see it's a very simple file here. Basically, Docker Compose files specify services, so you could have multiple services here. Our application is really simple. It just contains a web service, and this is basically everything about the web service. It's saying build the web service based on the Docker file and expose port 5000. If your application required multiple services in it, you could add them here and do something like, it would look like something like this, right? You would have like database, and then I think you would use image, and you go like MongoDB, right? And that would be like sort of a, got to make sure the alignment's right here. So this would be like sort of like a traditional web database application. You have your web server and then your database server using MongoDB, and the two could talk to each other. But we're just going to keep it simple for now. We're going to take this out and just make sure that our basic web server works. So to test that out, we're going to open up our terminal, clear the screen, and check out our commands. So the first command is to do Docker Compose up. And we need to do that in the Vagrant /Docker directory, because this is where our Docker file is and our Docker Compose file. So I'll run that, and it's doing the build of the image. So it's building up our image, and then it's going to run the container. And again, if you're new to Docker, just try to follow along if you can. And if you want to learn more information about it, I have a course up above. So it looks like our web server came up. You can see that it is running on this IP address, this port. Let's pull up a new terminal. And I need to go to my code projects, DevOps project. And then this is where my Vagrant file is. So I'll go Vagrant control. And I need to SSH into control. And the reason I'm doing this is I want a separate connection to test my web server. So if I clear this and go curl node 1 5000, and you can see it says hello world, I am, and then it gives you a long string. So let's think about this for a second. So we have a container running on node 1. You can see the request came in right here saying get HTTP 200 OK. So it all looks good. But what you might be wondering is why the host name came up as this. Now to explain that, I will go into node 1. And if we do a docker ps and resize that, you can see that is the container name. So I hope that makes sense. Basically, the application is running Flask within the container, and then when the Flask application asks for the host name, the Flask application is running in the container, so it returns the container name. Let's go ahead and get this container running on all 3 servers. Now, the best way to do that is to use an orchestrator. So we're going to be using Docker Swarm, but there's other orchestrators that you can use just the same. And the most popular one out there you've all probably heard of is Kubernetes. So you can do this just the same on Kubernetes. Kubernetes is a little more difficult to get into, But surprise, surprise, I do have a course on it that is about an hour and a half, 2 hours long. So if you want to watch that right now or after, it's a good way to get into Kubernetes, and you can take that and move that application to Kubernetes. Or you could follow along here and use Docker Swarm. And Docker Swarm is a really good way to learn orchestration. It's really simple. So let's go ahead and get Docker Swarm set up on all 3 nodes. So if we want to get Docker Swarm set up, we could go into each of our nodes manually and install it and configure it. But instead of doing that, let's use Ansible to set up and install Docker Swarm. So to get Docker Swarm installed, we're going to go out to GitHub and grab a playbook for it. So I have one here, which is DevOps Journey Ansible Swarm Playbook. And you can see that I forked this directory from someone else's that I found out on the internet. So one thing as a DevOps engineer is you're not going to be writing everything yourself. You're going to be using the open source community to find other projects and find what other people did to solve problems and use their work when possible. It's going to save you a lot of time. So we fork this directory, and you can see that there's quite a bit to this playbook. But if you have a look at it, basically it sets up Ansible Swarm, it sets up a master, and then it sets up the workers. So we'll probably have to do just a little bit of customization, which is probably just going to be the inventory file. We probably need a group named worker, and then one named manager. And that should be it. So let's take this, go back into our control station, and go git clone, and then throw in the directory. It has cloned it out. If we go in there, do an ls, you can see all the files there. Let's nano my hosts, and I am going to grab my one from Ansible here, paste it in, and then there was those 2 groups that we had, which was worker and manager. So we'll go manager, worker, and so manager will make node 1, and then worker will make node 2 and node 3. So we'll go node 1, node 2, oops, and node 3. And I think this should be enough. Let's go ahead and try to run the playbook, and if we run into any issues, we'll just troubleshoot them and see what we can do. So let's go Ansible playbook, and then specify our inventory file, which is my hosts, and then it was called swarm.yaml. Put in the password. So it looks like we have an error here. Node 1 installed okay. Node 2 and node 3 did not. Let's have a look at their playbook again and see. It does mention, you see this IP address doesn't look right. If we go ifconfig 10. So this is the IP address we want to use, right? Well, we want to use this subnet. We want to use this subnet for node 1, node 2, node 3. I guess this is the first interface. We don't really care about this IP. So there's something about the playbook using Eth0. We want it to be using Ethernet 1. So let's go here and just look. So you can see it's hard-coded F0, F0, F0. So let's change that in the playbook and see if it fixes our issue. So I'll go in here, Docker, or it was, I don't have it in here. I was running it from the root directory, so I don't have access to it. So let's actually take this. We'll go to Vagrant. This way I'll be able to access it in my Visual Studio Code. So git clone, reclone this. Oh, take that stuff out. There we go. Cloned over. Swarm. And then I have to recreate that host file. Actually, let's copy it over. We've already created it, so let's just copy it over. My hosts to my hosts. Okay, there it is. And do we have that old? Oh, before we run the command, let's actually go into Visual Studio Code and make that change that I was mentioning. Ansible Swarm Playbook. Let's go into swarm.yaml and then f.0. You can do a find replace all, but I'm just going to do this. There's only 4 of them. Okay, so changing this, it's going to be using eth1, which is our 172 subnet, which Swarm is installed on. So rerun this, Vagrant, and this should go out and rerun it, and we'll see if we get the same error. All right, so it looks like it finished okay, and that last step is successful. So it joined the cluster. So we have a full Docker Swarm set up here. Let's go into one of the nodes and just verify that Docker Swarm is set up. So we'll go SSH node 1, and to verify it, we'll go Docker node ls, and there you go. So we have our 3 nodes in the cluster, node 1, node 2, node 3. All the statuses are ready, and this one's the leader. So the leader is basically the manager, and then the workers are node 2 and node 3. So that's pretty convenient. And imagine if you had like a 20 node cluster, how easy that is to just get Docker Swarm installed on all the nodes and set up, and everyone joined to the cluster. So that just shows you the power of Ansible and how great it is. Okay, so let's move forward here. I'm going to go back into that Vagrant Docker directory. And if I do Docker PS, you can see I'm still running this container. And this is running through Docker Compose, created a container. I want to take down this container and have it running on the Swarm now. So if I just go Docker Compose down, this should see the Docker Compose file and then just kill all the containers related to it. So make sure you're in this specific directory when you run this command, otherwise it's not going to work. So you can see that it removed everything about that container. Do Docker PS, there's no containers running. So now we're ready to move forward. So one convenient part of Docker Swarm is it can read your Docker Compose files and launch the container and have it managed by Docker Swarm using that Compose file. So to do that, we just need to go Docker stack deploy, and then we specify a Compose file, and then we'll say Docker Compose, and then we need to give the service a name. So I'm just going to call it my app. And then we get an error. and it's saying the image reference must be provided. So there's one change that we actually need to make in our Docker Compose file to make this work. And I'll show that here. If we go into Docker Compose, we have this build parameter. So Docker Swarm doesn't want to build the images. It wants you to specify an already built image. So I'm going to go like this, image, and then I'm going to specify this. Now to explain this, this is my actual Docker Hub. So this is going out to Docker Hub and it's pulling down my image. So you guys can use this same image name and run this as well, and it should work for you. This is a public repository, so it's going to go out and grab my image that I've already built. And make sure to take that out and go back into the command prompt. And we should be ready to bring our service up. So let's rerun this command. And it looks like it is working. So let's do a couple of verification steps. So if we go docker stack ls, you can see that my app is running. The orchestrator is Swarm, and it's just a single service application. If we want more information about this service, we go docker stack services my app, and you can see that it's running, it's replicated, and it's a single replica. So you can have multiple replicas, and that's what we're going to do here. We're going to scale up our application to 3 nodes. So if we want to scale up our application, we can do that very easily with Docker Swarm by going docker service scale and then specifying this specific name, which is my app, and then the service name, or my app underscore the service name, and then equals and the amount that we want to scale it to. So let's do it to 6 actually, because we're not limited to just 3. We could have as many instances of this application running on our nodes as we want to. You're only really limited to the amount of CPU and RAM that you have. So now that we have that, let's rerun these commands. And you can see replicas is 6 of 6. So we have 6 instances of my app underscore web running. And if we want specifics of this, we go docker service ps my app underscore web. And there you go. You can see 2 instances on node 2, 2 instances on node 1, and 2 instances on node 3. So it's getting load balanced nicely there. Now, if you want to, you can go back to your control station and then do curl node 1 000, or port 5000, I mean, right? And you can see that you're getting the 2 different host names, right? Because it's load balancing on node 1 between the 2 different containers, this one and this one. And if you change the name, node 2 does the same, the load balancing between the 2 containers within it. And then node 3, it's load balancing there as well. Now, if you wanted to load balance between all 3 nodes, you could do that with a load balancer. You could use something like Nginx. You could use DNS load balancing, or you could use a Docker Swarm service load balancer. There's quite a few different options for that. So in this video, we learned how to provision, configure, and orchestrate multiple servers to run a containerized application. In future videos, I will show you how you can use Terraform to move this lab onto your favorite cloud provider. But until then, if you're interested in learning more about DevOps, check out the other videos on my channel. Thanks again for watching, and I'll see you all in the next video.